Okay, I think we are going to get going, everybody. So, welcome, hello, and it's great to have you on our Cassandra Masterclass webinar. On this Masterclass today, we're going to be introducing and unpacking all about misdiagnosing the Cassandra problem. I'm Steve Benton, and I lead the community engagement here for AxonOps, and I'm going to be your host for today's masterclass. Now, of course, with any masterclass, and we have run a few of these now, we have to have our masters, and today we've got two of the finest in the house with us. And so first up, we've got John Haddad and we've got Jordan West. So welcome, guys. Great to have you joining us. Why don't you share a little bit about yourselves and what you're going to be covering today in our masterclass before we get going?
Yeah. Thanks, Steve. So I'll kick things off. Little intro in case you don't know who I am. So John Haddad, I've been involved with the Cassandra community for 12 years now, which is kind of it's always a little bit weird to think about that. Like more than a decade of my life has been involved with this. I've my career has been a lot of fun. I've gotten to work with some amazing folks at DataStax, on the Cassandra team at Apple, on the database team at Netflix, where Jordan and I actually worked together on quite a few production issues. And after Netflix, about 2 years ago, I started up my own consulting company. So I do a lot of Cassandra stuff now, a lot of performance work, a lot of tuning. And Jordan and I run a training together, and we're gonna talk about that in a little bit. But yeah, it's been a ton of fun, and we're here to share some of the knowledge that we've gained, some of the stuff that we go over in training, and kind of talk about one of these issues that we've actually spent quite a bit of time tuning over the years, and I fixed on a lot of clusters. So this is, if you have an older cluster especially, this is going to be really, really helpful.
Brilliant.
Jordan?
That's great.
Thanks, John. Thanks, Steve. Excited to be here. I'm Jordan West. Like John, I've been working on databases for longer than I care to admit these days, probably also around 12 years. Been doing Cassandra a little bit less, about 8 years. I'm a committer and PMC member. Like John, I've had the privilege of working on some of the largest deployments of Cassandra in the world, both at Apple and at Netflix. And I've had also the privilege of being deep in the code base and being a contributor to code changes as well as an operator. And so that perspective has sort of developed a lot of a chunk of the content that we'll talk about here today and in the training that we'll introduce in a moment. But before we do that, let me just kick it back to Steve to talk a little bit about AxonOps, which is one of the tools that we're going to be using in this masterclass today.
Great, thanks, Jordan. Thanks, John. It's great to have you guys with us. You have a massive following. We've got the highest numbers on with us today. We're going to check the numbers a bit later on just to see how we're getting on with that. Well, I know we nearly had 200 registrations, which is absolutely fantastic. So if you're followers of these guys, thanks for joining us today. And as Jordan said, AxonOps are hosting this webinar today, and I just want to just point out a couple of things. And it's just one slide, and I promise you this is the only marketing slide that we've got. Okay, but for those that don't know AxonOps, AxonOps unifies the monitoring and operations of Apache Cassandra and now Kafka as well in a single intuitive user interface. Now, for years, there wasn't really anything like this around, which was a pretty big problem. So it was built by a team of veteran data platform experts who were at the time pretty frustrated with a lack of effective tooling. And so today, we have AxonOps that now meets the demands of critical workloads globally across multiple industries and use cases. So there we go. There's a little bit about AxonOps, and as Jordan said, you're going to be seeing a lot more of that today and how it can really help you, in what we're going to be showing you. So if you've just joined us, great to see you coming in. We've got quite a number of people joining us. So if you just joined, special welcome. You've not missed too much. I just want to let you know a few more things, and I'm going to hand back to John and Jordan. So one of the things I wanted to let you know about was we've got something really special in the masterclass. In fact, we've got a couple of things, guys, haven't we, that's really special for this time. Normally we would just run for 1 hour, so we build this for 1 hour today, okay, but we are going to go beyond the hour. So if you can stay with us for for a little bit longer, we're going to drop into something called Masterclass After Hours. Okay, and that's going to really be an opportunity, if you can hang around, where we're going to be answering your questions, and you'll have the opportunity to push a few questions out to John, and hopefully Jordan as well. John's not 100% sure if he's going to be with us. Hopefully he will be. We're not going to let you go, Jordan. We're going to keep you with us, and there's going to be plenty of questions coming in. And hey, guys, look, it's a bit of free consulting. He doesn't want that, right? So hang around and push the questions out. I just wanted to point this out as well. You will see that you've got your Q&A there, so start getting in there with your questions. You can keep them flowing throughout the first hour. If we get time, we'll pick a few of them up. If we don't, we're going to the after hours session a little bit later. Now, I just wanted to call out something that is really, really very, very good, and we're really pleased to be able to announce this. So it's very, very exciting. You're going to be hearing, in fact, a lot of today's session really is what you guys do, isn't it, in your training session that you do, which is a real hands-on training session. Now, these are paid for seats. They cost £2,500 to join, or 2,500, should I say, for those of you that want to join. But we've got a seat to give away free today, haven't we, guys? We are going to give away a free seat on your next training session. Okay. Now, you're probably saying to me, Steve, what do we do? What do we have to do to win this? It's very simple. You've just got to stay on for the first hour. If you stay on for the first hour, we are then going to do a raffle, or not raffle, but we're going to do kind of like a lucky dip, if you like. We're going to pick one of you guys out, or girls out, and we're going to let you know over the next week who that person is. But listen, I've talked enough. We spent enough on the introduction. We want to get right into today's session. So I'm going to hand back to John and Jordan, and sit back, everybody, and enjoy.
Awesome. Yeah. John, you want to tell folks a little bit about the training, and then we'll dive into the deep content here?
Yeah, absolutely. So essentially what we have here is a course that's focused on taking people that are used to operating Cassandra in production already and basically elevating your skills. So this isn't a beginner course. It's definitely not for people that are not familiar with the fundamentals of Cassandra. This is if you've got a production use case already, you have production environment, and you basically want to be able to diagnose problems quicker. When you're doing performance tuning, know the right things that you're tuning. When there's issues in the middle of the night, how to correctly diagnose them. Because if there's performance problems are difficult, because if your cluster isn't tuned well, then you can end up in this spot where you push way more load onto your cluster than you had originally thought that it would be able to handle. And if it's not tuned correctly, then it might not perform so well. And this is partially due to the fact that Cassandra is the configs that you get out of the box are great for your local laptop, and that's really the config was designed so that you can work on your Cassandra locally. It's not so great to put into production. And I found over the years, I've worked with hundreds of teams, I have found that people generally just put stuff into production. They go with the base config, and you're leaving a lot on the table, and it ends up being really expensive. And so in my experience, I've found that you can improve Cassandra's performance both in terms of throughput and latency by 10x. So basically what we have here is this course that teaches you how to be really, really good at this stuff, like operating at the highest level. And you can take these skills anywhere to any database. So it's a problem-solving technique, and it's a way of doing analysis that I've found is incredibly efficient.
And John, can I just say, this is pretty unique, right? I mean, you don't get this kind of stuff anywhere else, I don't believe, right? I mean,
to my knowledge, yeah.
Yeah.
So especially on the Cassandra side, because the tricky thing right now is there's a lot of really good content available. Like there's I helped build DataStax Academy almost a decade ago, and there's a lot of really great content there, and the the folks at DataStax put out a lot of really good intro content that teaches you about the fundamentals of Cassandra. But what Jordan and I have built is a hands-on class. Like we actually set up real clusters with real problems that we've seen in production. Like Jordan and I have worked on a ton of just wild production issues for years, especially when I was at the last pickle. Like when things would go wrong with somebody's cluster, you know, people like I would, if it was in the US, like I would be trying to fix it. So I've got just years of muscle memory to approach this problem solving situation, you know, figuring out how like to figure out what's going on with a cluster can be really tricky if you don't follow like a methodology. And I talk about this a lot. Methodology is super, super critical because otherwise you're just kind of throwing darts at the wall. Like it's really, really easy to just say like maybe it's like I've literally seen people say maybe it's GC without looking at GC logs, and it's like, well, that's not how it works. Like you actually need evidence. So the class we set these clusters up. We have the teams. People don't know, like people have information as to like the things that they need to look at, and they have the problem solving technique, but they don't know what's wrong with the cluster. So the goal in the class is to get together in a safe environment that's still broken. So it's a broken environment, but it's a sandbox. It's okay to mess around with. And what we do is we kind of go through this process. At first, it's slow because you might not, you know, you might not be used to it, but by the end of the class, what we've seen has been incredible. The way that the people go from, you know, unsure about how to solve production problems to just attacking these environments and being confident in their ability to fix things. It's really been amazing. And we've done several public trainings now. And we've also done a bunch of private trainings. So we come in and we'll do you know, we'll do the same training, but within a team. And that's great because people can bring us you know, questions about their environment, and we can tailor the class a little bit to help people you know, understand like their exact problems. And it's just it ends up being a ton of fun because you really, it's kind of a game, right? Like figuring out how this stuff works and getting that really rewarding feeling of fixing something that you didn't know that you could fix. It's just it's great.
John,
There's
you
nothing
whet
like
you whet the
learning.
appetite. You whet everybody's appetite, I think, and they're all raring to go. I know you're going to give them a little bit of a taster in this session now, so they're going to get some insight from it. So that's great. We can't wait to get going. So guys, let's find out. Misdiagnosing a Cassandra problem. What's it about? What are we doing?
Yeah, I think we're going to start by introducing a little bit of that framework John mentioned.
Yeah, exactly. Jordan, am I introducing this? Is that what we agreed on?
Yeah, why don't you go for it?
All right, I'll talk about this. So the OODA Loop is something that I learned back when I was at the last pickle. For those of you that don't know who Aaron Morton is, he's been involved with the Cassandra project even longer than I have. He set up the last pickle with Nate McCall and the two guys. They're both on the PMC. They've been involved with this project forever. And when I got to the last pickle, one of the first things I learned about was this OODA Loop, and it was invented in the by this like Air Force colonel. I forget his name, but it's essentially like, how do you handle problem solving, especially when, you know, when you're like in a dogfight. I guess it's like you got to be really good at problem solving quickly. So we basically took this problem solving technique and internalized it into what we do. And you know, you might already do this naturally. Like if you've solved a lot of problems over the years, this is kind of like, this is the way that you do it. But if you're not used to it, it can be really, really helpful to sort of internalize this framework and do it explicitly. Each phase of this, like you kind of almost call it out. And you're like, okay, now I'm doing this. And as you get into it and as you do it over and over, it starts to become more natural, and you find that you become a lot more efficient at solving problems. So the first stage here is observe, right? This is you're really just gathering information. So it's really, really important to not jump to conclusions prematurely. And so the first thing that you're doing is you're gathering up info. This can be high level metrics, like maybe you'll open up your dashboard and you'll see that your cluster is doing X requests per second at this latency with this many errors, right? It's always important to look at throughput, latency, and error rate. And you want to look at it at the cluster level. You want to look at the individual node level. Do I have outliers? What do I see? Like, do I have high CPU usage, right? Like Brendan Gregg invented something called the use method that I really like to leverage in this as well. We look at every system resource, and we ask ourselves, have we like what's our utilization? Are we oversaturated? And what's our error rate? And we gather up as much information as we can, and then we use that to build a mental model. That's where we orient. So the second phase of the loop is basically saying, okay, I have all this information now. Like, what could possibly be, like, what could be happening? And then you make a decision. What are we going to do next? We could gather more information, or maybe we have enough information to take a stab at what we think is going on. But it's called a loop because you don't just do it once. Like you're literally just going through, and you keep going through this and revising your mental model. And when you actually perform actions, an action could be, I need to go get more info. Like maybe I need to look at some other metrics, or maybe I need to SSH in and look at a machine and figure out what's going on. Or maybe it's like, hey, we think that the problem, like we know it's GC because we've looked at the logs. We see that we have, GC pauses that are too frequent or too long. Or we look at our thread pools, like we'll be looking at a little bit later. And we essentially just kind of go through this loop over and over, and eventually we solve the problem. And it's a proven technique. It works really, really well. If you're not doing this now, it can be incredibly helpful to put this into practice.
One of the reasons I love this framework is watching others operate in production. Often people want to go right to decide effectively. They want to make a change. They feel a pressure to make a change. And sometimes that can work. You can get lucky. And other times it can exacerbate the problem. Some of the worst incidents I've ever seen have actually been like medium severity incident that someone sort of like jumped the gun and then took a step that exacerbated the problem instead of made it better because they moved too quickly and didn't observe sort of the system as a whole and orient themselves. And the last part that I'd like sort of hammer on there is the mental model bit. It's really important to have a mental model of how the system works. And that's a little bit of what we want to show you today. And so we'll start to dive into that. But it's also our goal in the training is to help you build a mental model for what the system that you're operating is doing.
Great. Listen, I'm going to stop sharing my screen, so I know that you got some things to share as well. So I'm just going to jump off here.
Yeah, John, you want to throw your screen up, and I'll tell folks a little bit about our environment and our workload today?
Yeah, I will. And just a heads up, I just restarted our workload to put it at 20,000 requests a second. So it's going to be ramping up right now. It's been running for a little while in the background, but I want to have it run at a constant rate so that we can see what's going on. So let me share this.
Awesome. So what John is pulling up is using the lab environment that we use in training. This is an open source tool that we also encourage folks in the Cassandra community to use to experiment with Cassandra. We call it EasyCast Lab, and it comes with another benchmarking tool called EasyCast Stress. If you've been in the Cassandra community for a while, these tools used to be called TLP Cluster and TLP Stress. So John and I have used these for our training, as well as when I qualify patches or releases for Cassandra, I'll make sure that they run with this tool. John and I have done benchmarking on a few patches with this tool. So it's a robust playground for working with Cassandra. And so it's why we use it for our training and for this masterclass here. What John has at the top is the stress workload running. So that's generating traffic for Cassandra. And then we'll talk on the bottom a little bit about our data model here in a moment. The workload that the stress is running is a lightweight transaction workload. So if you're familiar with Cassandra, this would be local serial or serial is what we call. And then the schema definition for that table is below. So we have a table in the easy cache stress key space named LWT. Those are just the default names that the stress tool picks. And we can see it's a really small table in terms of like what the schema is. We just have a textual ID and an integer value. And that detail is going to be really important for our like investigation today. Before we go further, let me grab a couple of the live questions. John John White asked that these tools are working on AWS. That's correct. Could they be configured for other clouds or for local clusters? The tool doesn't currently support that because for our needs, Amazon has been what we've needed. The code is factored in a way that if people would like to contribute other clouds, we would love that. This is largely driven by our needs and the community's needs right now. So if the community has more need for local, which has also been asked, or Kubernetes, Azure, other cloud tools, we'd love to see that. We just haven't built it ourselves.
Yeah, it's everything has over the years has been driven mostly by consulting needs. So the 3 years I spent at TLP in the last 2 years working independently, when folks need something benchmarked, the question is like, do you want this benchmarked in Azure? Do you want this benchmarked in Google Cloud? And usually, because I'd say 90% plus of clusters that I work with are in AWS, it just kind of by default became the tool of or the cloud provider of choice. But as Jordan said, there is nothing that prevents us from adding support for multi-cloud. We actually do behind the scenes. It does all the provisioning with Terraform right now and creates AMIs using Packer. So they're all multi-cloud tools. So it's really, we've set it up to be future ready in the future. Yeah. Exactly. We just need somebody that cares enough to make the investment in it.
So one other question from Keith McKiff talking about YCSB. I see a lot of benchmarking from YCSB. Is this a stress tool that you'd recommend? Why or why not? YCSB is kind of like the lingua franca of SQL benching, like relational database benching. People have used it to translate to Cassandra to try to draw some parallels between those systems. I believe, and John, you can share any disagreements. Our stance is that Easy Cache Stress is the best tool for benching Cassandra specifically, and that's because it comes with workloads that are specific to Cassandra, like LWTs. Whereas with YCSB, you may be deciding, whether or not how to use LWTs for your YCSB benchmark and that sort of thing. A few more questions about the workload, and then I'm going to share our dashboards for today, and we'll take a quick look at Axon. Abhijit Dubey, you asked about if LWTs, you mentioned they're a bit infamous due to increased latencies. Stick around because we're actually going to talk about how to bring those latencies down. That's the exact focus of the talk today. The LWTs are more expensive, but there are many performance tunings that you can do to make them perform better. And we're going to explore a chunk of those today. There was another question here about cluster size, and we're running this test. So this is just I believe it's a 3-node cluster, John. It's relatively small. Yeah. One thing John and I have found in testing is that a vast majority of performance issues can actually be shown and tested on smaller clusters and then taken to larger clusters. So it's rare that we'll set up with our lab tool like a 100-node cluster.
Yeah, and to add to that, it especially running on your laptop is a terrible way to benchmark Cassandra because it's not actually distributed. First of all, and typically people are running it on non-Linux OS. So if you run it locally in Mac and you run it in production on Linux, it doesn't really help to do your testing locally. And the other thing is that in a lot of cases, running in smaller nodes, for instance, this node, I forget what the exact size is, but it's not a particularly large node. you encounter your performance problems a lot earlier. So when it comes to like when it's a resource utilization problem, if you can hit the limitation of the underlying hardware earlier, it makes it in a lot of cases it makes it a lot easier to figure out what's going on, because you're just like, when you hit 100% CPU, you're like, okay, like, what's taking up the CPU time is like the question that you need to be able to answer. And it doesn't matter if you have 1,000 cores or you have 8 cores, um, from the standpoint of where your CPU time is being kept to a degree. Like if you have if you actually had 1,000 cores, you would hit a totally like some odd problems, mostly due to threading, but um, and potentially like lock contention, but uh, generally most problems can be reproduced on smaller clusters. So I think this is like 8 cores and 30 gigs of RAM.
Yeah. And there's a few other questions I see coming in. We'll take those towards the end of the Q&A just because they're a little bit more detailed. So what I have up here is the AxonOps dashboard for our cluster. So ECL, EasyCast Lab sets all this up. And so John and I are using this dashboard to for today to sort of show performance and stuff like that. And so we'll be revisiting this dashboard from time to time as we work today. And we'll start here on the coordinators page. And just to sort of start to observe, we can see that we're pushing over 40,000 or approximately 40,000 reads per second through this cluster and about 20,000 writes per second. So pretty good workload on this small 3-node cluster here.
Yeah. Jordan, can you go to the system page?
Yes. And OODA, this is AxonOps. So this is the tooling by our fine hosts here. And we use this for our training because it is a great available tool to the Cassandra community user base. And you can get, Steve, correct me if I'm wrong, I believe it's 3 or 6 nodes of monitoring for free.
It's 6, yeah.
Yeah.
6.
And so we use this tool in our training, and it's why we're using it here today as well. So yeah, John,
We'll give you some links later on that, so don't worry. If you don't know where to go, we'll signpost you a bit later.
Yeah, all the so essentially, we've actually built in support for AxonOps into EasyCast Lab. So one of the really cool things here is that because Jordan and I are also working on like doing evaluations for patches, and Jordan and I have a really interesting patch that's in flight right now that should massively improve, um, uh, massively reduce the cost of running Cassandra, because because we have so many tests, because we need really good dashboards. We actually built support for this, and so right into EasyCast Lab. So when you start up EasyCast Lab for the first time, it prompts you for like your AWS key, but it'll also prompt you for your AxonOps key. And the really nice thing about this is when you spin up a cluster, like we just spun up this cluster an hour ago, and this came with it. AxonOps support came with it out of the box. It automatically registered the cluster. Everything just works. So if you're interested in building a lab environment and you want, if you want to create a 3-node cluster or a 6-node cluster and just figure out like, okay, how do I reproduce this problem? It kind of was a no-brainer for us to include support for this, because it really, really helped us solve a bunch of problems. And we won't get into it right now, but the optimization that we're talking about will literally cut the cost of running a cluster in half if you're on EBS. And we have tons of screenshots from AxonOps. Like it made it so much easier for us just to prove out that the patch works as expected. So yeah, pretty
so
fun.
John, you want to start to dive into our problem here today?
Yeah, let's do it. Let's go. Let's hit our phase 1 of the OODA loop. I mean, we know we're running a lightweight transaction workload. It's the only thing that we're seeing. Why don't we take a look and start with at the high level? Like, what do we? I know you mentioned the number of reads that you were seeing. And the interesting thing is those reads are coming from the lightweight transaction queries. The actual number of explicit reads is quite low, but we're actually seeing one of the things about lightweight transaction workloads is that it actually is a read heavy workload, and most people may not be aware of kind of the little subtleties of how lightweight transactions work, and how disks work and how CPU works and thread pools. So if you start running a lightweight transaction workload and you haven't done any tuning and you haven't done any investigative analysis, you might just look at these numbers and you're like, well, this isn't great. Like my latency is, I'm doing 20,000 LWTs a second, but my latency is like 100 to 150 or something like that. Like, what is going on? I think those are the internal numbers that you're seeing now. But then you look at the internal numbers and you see the internal numbers are like single digit milliseconds. And it's like, well, why would this be happening? And a lot of teams, in my experience, I've found that the overwhelming majority of teams have just gone, well, Cassandra is not good at LWT, so we shouldn't use them. And as a result, I've seen it like banned from any number of companies. But the reality is
That
that
literally came up today, right? Like that was one of the first questions today.
exactly. And that that misinformation has permeated throughout the community that like Cassandra can't do LWTs or they're bad or you should never touch them or whatever. But the reality is that there's just a handful of tiny things that you can change, especially if your cluster was created before version 4.0. And I'm going to talk a little bit about that in a minute. But
yeah, let's even look quickly at those numbers, right? So in the observe thing, it also matters what numbers you're looking at. So to John's point, when I had this view before, while he's seeing on the client side, latencies of 150 millis, this looks pretty good. Although 4 or 5 milliseconds for Cassandra writes is actually really bad. Your writes should be around a millisecond or lower on average. But what's interesting to note is I'm looking for 75th percentile. If I pull that up to the 99th, which is where you should normally be looking, we're talking about 40 milliseconds. That's abysmal for Cassandra write performance. 10 times worse than I would expect it to be and 10 times worse than our 75th. And if we go one more level up, we see what John's seeing with the 99.9th percentile or near our max latencies. And those are reporting in the hundreds of milliseconds. And as John said, the thing here to note is that LWTs are a read-heavy workload. We can actually see, John, do you have any reads on the cluster, or are you just doing LWT writes currently?
So right now we're getting around 19,000 lightweight transactions a second with 200 reads a second. So this workload is configured to do 20,000 operations per second. And that's actually something that's just set at the EasyCast stress level. So you just do -- rate 20K, and then what percentage of those you want to be reads. So this is like 1% reads.
There's a question about CPU and throttling, but there's also a mention that this page doesn't show the CPU. Just to share, this dashboard has several other components. So I'm just showing the coordinator level metrics currently. There's system metrics for CPU, disk, memory, network, and so we can pop some of that out as well. But yeah, coming back here, right? So with what John said, we can sort of realize that every LWT that we're doing, we're all like every write is also incurring a read, and that's because the algorithm has to do some bookkeeping, and so we're seeing that bookkeeping happen. And there are a whole bunch of other patterns where Cassandra reads before writes, not in a normal like put and get kind of workload, but counters are another example. And then what we're showing could also impact small reads as well.
Yeah, and this is the area, and again, this is way worse with older versions of Cassandra because of some of the defaults that we had in production. So, we changed this, like 4.0 came out a while ago, but a lot of people are running, like the interesting thing about Cassandra is that people will sometimes stand up a cluster let's say in, some of the clusters that we worked with at Netflix were around for like literally over 10 years. Like I remember one of the ones I shut down. I shut down the first cluster ever started at Netflix, and this was, I think it was started in like the 0.8 days or something, or 0.7 or something like that. So uh, there's a lot of environments where you might be running 4.0 or 5.0 now, but if this was created in 3.0 or 2.1 or something like that, you might be running into the same problem that we're going to show here. So as Jordan mentioned, it's small reads, and lightweight transaction workloads are generally tiny reads. Like we want to update a single, like your password or your email, or some small bit of
Even
information.
a small user record is tiny. We're set like under a
Exactly.
kilobyte, right?
Exactly. And so one of the things that you find is that there can also be several things that are a problem. People want to point to one problem, and it's like this workload, for example, has a few things that we're going to optimize that make it a little bit better. And so when you do a read with Cassandra, the thing that's really helpful is to understand what the read path looks like. And Jordan, while I'm going to let you talk for a minute, I'm actually going to pull up a flame graph. I'm going to take a flame graph right now of what this environment looks like, so we can just get an idea, because people are not, I think, aware of how easy it is to profile a system. This is something that we've built into EasyCast Lab. It's incredibly easy. In fact, let me share my screen,
Yeah.
and I'll show how to do that, because this is probably, being able to take a flame graph and interpret it is one of the most useful skills that you can have in your
Yeah, so why don't you
toolbox.
show folks how you're taking that, and I'll talk a little bit more. So like John mentioned, the flame graph is probably one of the most useful tools, and it's one that we use heavily in our training and in our production debugging. Whenever I'm kind of wondering what a node is doing, there are two options. Looking at the stack traces and looking at a flame graph. A flame graph is effectively looking at a stack traces, not over time, but we take flame graph over a period of time. So if you look at John's screen here, it's running for 60 seconds. What it's doing is it's sampling the stack of the Cassandra process over and over again in these 60 seconds. And then it's creating an image of what stacks dominated that minute of time. So what you get is this image that is essentially relative. So like the amount of space taken by a stack is the amount of that 60-second interval that was taken by the stack approximately. And that can help you understand where a Cassandra node is spending its time. Is it spending its time doing reads and writes? Is it spending its time doing compaction? And so again, this is all part of that observe stage, and then later that using that information to orient yourself to once again understand what the database is doing. And so John, when you're ready, why don't you pop that flame graph up on the screen, and we can talk about it briefly before we get into fixing this cluster.
Yeah, definitely. So let's go here. All right. So the interesting thing that you can get out of this, and if you haven't spent a lot of time looking in the code base, this might seem really intimidating, but there are clues here. And so you don't have to know everything about the internals of the Cassandra code base. And this is actually a great way to learn the code base. To be honest, this is getting started with flame graphs is how I got started learning the Cassandra code base, because I didn't really, when I wasn't sure what to look at, I would take a profile, I would look at the classes that are represented here, and I'd go, okay, this is what I need to understand. So you don't have to wrap your head around the entirety of the code base. You can use this as like a map to figure out like what to look at or what you should even care about. And the interesting thing here is, like, you can see, and you probably would expect this, here we have this like Paxos single partition read. We have a single partition read over here. There's actually a lot of time spent doing reads. Like it actually is spending most of its time on reads. So if we do, let's see, we look over here, we see save Paxos modification statement, select statement. Okay, so like let's look. So we see select statement. What's that mean? So we can go up here and we go right, and this highlights this, and we can see match down here 26%. So it turns out that even though this is a LWT workload where 99% of what we have going on is writes, we actually see that we spend 25 or 26% of our time doing reads. And this is actually on, these are on NVMe disks too, which is like interesting because there's almost no time that we should be spending waiting on IO, but we are spending quite a bit of time in select. So this is part of our observe phase. We go, well, like, okay, so if we got these lightweight transactions and we're trying to write 99% of the time, why do we spend 20 something percent of our time in reads? Like, that seems ridiculous to me.
And this is where mistakes can happen, is you may go try to optimize the writes and the writes are not your bottleneck. And so
exactly.
In your best case, like nothing good happens. In your worst case, you actually hurt the performance by like deprioritizing your reads. For example, maybe you start bumping the number of writer threads only. And that can backfire. Yeah, John, we should take folks through. Go ahead.
Yeah, I was going to say, can we jump into back into the dashboards and take a look at our thread pools?
Yes.
So now we're gonna shortcut some of this stuff because we only have a limited amount of time. We want to make sure that we get all this stuff taken care of. But now one of the things that's important to know here is that when you do lightweight transactions, you are, and with any workload, you're always limited by the settings for concurrent reads and writes. And because lightweight transactions take longer to execute, they still count against your concurrent writes, but they take longer to execute. And so you actually find that you need to do more of them concurrently. So one of the easiest things to spot is that we have all these pending tasks sitting around for lightweight transactions, right? Like these numbers keep going up and they go up into the thousands, which tells us that we're not keeping up with the queue all the time. And we should ask ourselves, can we handle more work, right? Because if we have pending transactions or if we have pending tasks, that means we're clearly bottlenecked somewhere. Are we artificially bottlenecked by the configuration, or are we bottlenecked by the hardware? So at this point, then we say, okay, what is our decision? Well, we're going to get more information. We're going to look at this. We're going to look at the system statistics and say, are we bottlenecked at the CPU level? And see here, we see not so much. So one of the first things that I'm going to do this right now, is I'm going to go ahead and update, and I'll do this in the background while Jordan's showing the screen.
I'll come back to the thread pools here for a moment. So John mentioned the read and write thread pools. And so those are taking the work of doing the reads and writes. There's also here in purple the native transport requests, and you can see those spiking as well. The native transport threads are blocked for the duration of the work being done on the read and write threads. So they're being blocked for the whole coordination of the request, the round trips for Paxos, etc. And so sometimes you need to bump those as well, because again, it's not that the system can't handle more work, it's that we've potentially artificially limited the amount of concurrent work we can do. And so, there are times where essentially we're sitting waiting for a disk and not doing anything when we could be doing more work and making more forward progress on other requests. Here we see an example of a huge spike. Almost a second's worth of requests at the peak here, almost 17,000. And this latency is like sitting in this queue is latency that your customers observe, right? So just here, it looks like about 20 milliseconds of our request is spent just waiting to do work. And so you have to factor these in. This latency here does not show up in Cassandra coordinator latencies either. So you may be looking at your cluster and seeing like, oh, I have phenomenal performance, and your customer is telling you, no, I have abysmal performance. And one of the reasons can be is because their request is sitting in this queue as we watch it spike to 120,000 while John restarts some of the nodes, I believe.
Yeah, this is also a general problem in observability that a lot of folks have, is they look at the internal database measurements and that's all they see. That's something that I really loved that we had at Netflix. Every application, because it was built from a consistent framework, automatically monitored all the driver metrics. And I absolutely love that because it's really critical. Like Jordan pulled up the metrics before, and it was like 40 milliseconds for the 40 milliseconds for the writes, but on my end I'm seeing like a much higher number. So the question is like, why do we have a higher number? What's going on there? What's the discrepancy? And a lot of it is that queue that when requests are queued that Jordan mentioned. It's you don't usually see queue time accounted for. Like at the storage engine level, you're not going to see it. You'll see that you did you did 1 millisecond reads, and you're like, great, that's awesome. But it doesn't take into account all the other queue time. So you have to have a holistic understanding. Getting high level metrics is good, and then drilling down helps you find the root cause of the problem.
I think that transitions us nice to a question from Joshua in the Q&A. How much do the Cassandra logs factor into the OODA loop when managing a cluster that can have multiple potential sources of traffic and activity? So the logs are super important. The first thing I'd say is what John just said is we advocate that you start from like the top level view. So if you had like a multi-region cluster, the whole cluster, and then zoom into like a region, and then potentially a rack or a replica set or a node. Where you go from there depends on the diagnosis. The logs are going to become critical as you start to zoom in, or sometimes can be helpful in aggregate if you have some of the log aggregation tools that are out there. So for example, like looking at like the rates of an exception in the logs over time or something like that. One of the reasons that I also find AxonOps to be really cool, and this isn't in even like tooling I've had internally, is they actually centralize parts of the logs into their UI. And so I've pulled that up from the bottom here. It's by default kind of like brought down here like this. And they do some of that aggregation as well. So you can see some of the log events over time and do some diagnoses from there.
Yeah.
All right, John, let's get this cluster performing well here.
Yeah. We need to get this thing under control. So one of the things that we mentioned, and we didn't get too deep into this, is the different aspects of the phases of Paxos. Now Jordan kind of alluded to this a little bit earlier, but I'll just go ahead and spoil the ending. When you take a look at these flame graphs, and it's going to depend on a lot of the system, the specifics of the system and how much data you have in your page cache and how efficient your page cache is. There's a lot of things that can happen here. Typically with workloads larger than memory, you end up having more requests go to disk. One of there are two big limiting factors here when you go to disk. Depending on how much data you're reading off disk, you could be seeing a lot of read amplification. And the biggest source of read amplification, or one of the biggest sources of read amplification, is actually put in place by your OS. It's called read ahead. So when you do a request to your disk, your OS will go, hey, like we're not just going to read the data that you asked for, we're going to read a little bit extra. And by default, we actually read a total of 128K, which is not great when you have really tiny reads. Like as Jordan mentioned earlier, lightweight transactions are typically over really, really small bits of data. Same thing with counters, same thing with just tiny read heavy workloads on like, let's say a user thing, we said less than 1K. So if you have to read 128K to only get 1K of data, like that is kind of insane. So one of the first things that I always recommend people do is adjust read ahead in their cluster. If you have a local NVMe drive, you're going to just set it to 4K. And if you're running on EBS, for now, you're going to either be setting it to 32K or 64K. It really is going to depend, and it's a complicated answer. Compaction, it actually needs read ahead right now. The patch that Jordan and I are working on will completely eliminate that need. But essentially what we're going to do is eliminate the source of the read amplification, and we're going to do it in 2 locations. So I'm just going to go ahead. I'm just going to knock that out now because it does involve a restart. So if you just give me a moment, Jordan, if you want to continue, I can knock this out.
Yeah, so let me talk a little bit more about read ahead and why it matters here. So in Cassandra, we think about, we have SS tables, they're sorted on disk, they're optimized for scanning, and that's true. But the vast majority of reads in Cassandra are single partition reads and sometimes even single row reads. And like John and I mentioned, rows are often small, less than a kilobyte. They can be bigger. They're rarely the size of like a normal read ahead unit, like 128K. And so what you're doing is you're telling, your resources like, hey, go read 128 kilobytes just to get me this like sub 1K record. And this is exacerbated, as John mentioned, there's 2 levels of this. One level is the system read ahead, and then the vast majority of us run Cassandra with compression on. Compression has a block size, and the minimum read we can do in Cassandra is that compression block size when you're using compression. So if you have a block size of 64K, again, the database is going to go decompress 64K of data just to grab your 1 kilobyte out of it. And you may say like, well, I have the page cache. Well, the page cache is the compressed bytes. So every time you're going to pay the cost of decompressing this data just to get that 1 kilobyte back. There are also some suboptimal ways that read happens. And so by setting, let's say, like your read ahead to 4K, and John, what read ahead or compression chunk size are you going to use as you fix things?
So for this one, because the records are so small, remember we looked at that when we looked at that schema, we only had an integer in there. I'm going to bring this down to a 4K chunk length. So what's nice is we're decompressing. We're talking about a factor of 16 here. So instead of decompressing 64K worth of data, you only have to decompress 4K. I've actually made this optimization in a lot of cases. I've done it in one of the biggest gaming platforms on the planet, and it went from every time there'd be a big event, the system would be just bogged down to silky smooth. And it's an incredibly easy optimization to do. People are scared to do it in some cases, but you shouldn't be. So we're actually just going to go ahead and we're going to do this now. Should we?
And just to show you, it's not just us. Sam from the audience shared that on RHEL 9, the default read ahead was 4 megabytes. They reduced it to 4 KB and saw their P99s cut in half. So this can be a huge win.
Yeah, I once worked on a cluster that had multi-megabyte for read ahead, and they were like, why is Cassandra so terrible? And I looked and I was like, well, you are pushing like 2 gigs a second of data through your page cache, like, but you're like doing hardly anything at the network level. So one of the things that you might find a really good clue in this situation is when you have megabytes at the network level and gigabytes at the disk level. And that just means that you generally have like a massive amount of read amplification. You're reading way too much off disk and you're trickling data out into the network. So what you want to do is alleviate, you want to identify that resource bottleneck and then understand what the root cause is of that bottleneck. And that's where we use flame graphs. We haven't gotten into Bcc-Tools, but it's a really great collection of tools that uses eBPF to help you understand the underlying operating system. Incredibly helpful. Jordan, I'm just going to also go ahead and make that compression change now.
Awesome.
So guys, just want to jump in really quick because time is always chasing us, and we do only have probably about 4 or 5 minutes left, and we want to take a couple of minutes just to help signpost our audience today in some of the things that we've been talking about. So we do want to just cover a little slide towards the end. I think for those that can stay, we've got Masterclass after hours or after dark, extra, whatever you want to call it. And I think you guys probably may even show some more things as well as taking some questions as well. So if you can stay, please do stay with us. I'm going to jump back on in about 3 minutes, guys, if that's okay, 2 or 3 minutes.
Yeah, that's great. And John, while you're recompressing, I've got a couple questions here that are open that I wanted to take. So let's see here. These are just some general questions, not necessarily about the topic today. Someone asked, what's the best tools for repair for Apache Cassandra? Open source, there's a great tool called Reaper. John has worked on that. And then also AxonOps has their own backup tooling that can upload to S3, has a lot of the same functionality of Reaper and integrates directly into AxonOps, as well as, I believe, Steve talking to other clouds and a local backup option as well.
What we'll do, I think, Jordan, as well, we'll probably take those other questions and we're going to flip them over to after hours or after dark. I keep getting it wrong. After dark, masterclass after dark. We're gonna flip them to that, because I know John's working on the baking the cake and getting it out of the oven, and it will be there soon. Okay.
Yep, it's
But
going now.
I'm going to flip this now for the next 2 minutes. All right. So if everybody can give me 2 minutes, I just want to share really quickly the last slide, because it is very important. If you do have to go on the hour, I really don't want you to miss out on this. So we're going to just quickly share now, and you're going to see the last slide that we've got here. All right. So let me just cover this off really quick, and then we're going to go straight back to John, and we're going to find out what's been going on with this cluster, right, John? We're going to have it all smooth and all working. Okay, all right. Okay, well, listen, I want to just draw your attention, everybody, just to this slide really quick, because you've heard from John and Jordan today. If you want to click on to their operational excellence course, you'll see the barcode up there. Click onto that. That will give you more information. So if you want to dig in a little bit more, find out some more about that, then do scan that now. This is the one time to get your phones out and start having a look. We've also got, I think it was Jordan, I think you mentioned, or John, early on, about the AxonOps free account for 6 nodes. You know, you've seen a lot now of the guys using AxonOps as part of their setup. We hope you like what you've seen. The good news is that you can now go and get this free account, and you can use up to 6 nodes, get your clusters connected straight away and start using it. What you'll also see here at the bottom left is the AxonOps workbench. Now, this is it's a quick short shout out really to AxonOps Workbench, which is an open source tool for developers. And DBS is currently in their final beta stages, and you can find out about it and install it on your PC here as well. So there we go. You see top right, book an expert clinic. We've got experts here at AxonOps. They're here to help you. All right. And so if you've got any Cassandra questions whatsoever, maybe even about this masterclass, but whatever it is, just book us a slot, and we'll get an expert out to you. Now, this isn't the only masterclass we've done, everybody. We've done a few others, and they're pretty good too. So you can listen to them on demand. If you click here, you'll get to see the other masterclasses we've done as well. So the next masterclass that's going to be coming up, we've got one next month, and it's a quick shout out to our very own master, Johnny Miller. He's going to be exploring why Cassandra and Kafka are made for each other. So that's all that I want to say about that. Please, we're going to be sending a recording out, so don't worry if you miss anything. You can go back over it again.
And John, also, or Steve, there was a question. Will you be recording the After Dark section as well?
We're going to record the whole lot, so if you do have to go, that's fine. But if you want to stay on, you know, this is a chance to be interactive even more with us now. Get the questions out there. For those of you that have stayed on for the hour, we're going to be putting you into that draw over the next few days, and we'll find out who the winner is to go onto the free training for Jordan and John. So we'll let you know over the next week on that as well. But look, we're still here. If you can still stay with us, that's great. But I'm going to stop sharing. I'm going to hand back to you guys to keep going. Keep your questions coming. Let us know how you're doing. We've got some really good feedback. We've got nearly 100 people that have joined us so far today. Fantastic numbers. Pleased that you're enjoying it. If you can stay on, we still got big numbers still on with us, guys. So look, the floor is yours. Come on, let's keep going.
You're motivated me to stay, so I'll stick around for a little bit of
Jordan
that after
dark. So look, you can't leave now.
I gotta take this one question that's been that I noticed here. Unfortunately, the Zoom scroll is not letting me see it, but
What was the topic of the question? I can read
it
it, John.
was about the getting started production page. The
Yes.
reason why it says, guess this page is pretty accurate. Yeah, I wrote that page. That's why it is the way it is. I mark that as done. In your experience, what was an OS that by default has the most problems and needed more tuning? Thanks, John White. To be honest, like I didn't really find there was a particular OS that needed more tuning. It's more about what version of the kernel you're getting. I tend to work with, I prefer Ubuntu because it gives me newer kernels. With newer kernels, you get more advanced eBPF tooling. And so it's not so much from a, like, what do we need to tweak? Because like, while there are some OS tweaks that you can do, like you can change like your schedule. Like, for example, if you're using NVMe, you should be using the Kyber scheduler. Most people don't do that. They just use the default, which I think is Deadline. And you end up just kind of pointlessly like limiting your disks a little bit. But the biggest tunings that you can get are typically in Cassandra itself. There's a lot of stuff around thread pools. There's a lot of stuff around compression, compaction. Compaction is super important. Like getting the right compaction strategy. I'd say most people, when they create a cluster, they just use the default, which is size tiered. And I'll be honest, size tiered is good at almost nothing. And if you're using 5.0, I don't think there's not a single use case I would put size tiered compaction in production with again. Like it's just there's just absolutely no point.
I would turn the question on its head and say the worst tuned thing is actually probably Cassandra out of the box. And so tuning it is the most important. That transitioned us nicely to another question, which was asking about Cassandra 5 for production usage. John, I know you have some experience and thoughts there. So the question is, would you already recommend Cassandra 5 for production use?
Absolutely. So Cassandra 5 has a lot of advantages over 4. I mentioned compaction already. Unified compaction strategy. So if you're using size tiered now, and you're before 5.0, get to 5.0, switch every single table from size tiered to unified. It's the actual parameters that you use are a little bit tricky, but if you are coming from size tiered, you're going to use the scaling parameters T4. That's all that you need to know for now. And the reason why you want to do that is because it works similarly to size tiered, but restricts the end SS table size by default to 1 gig. And the reason why that's so nice, when you expand a cluster, one of the optimizations that went into Cassandra 4 is the ability to stream entire SS tables at once. Now that can go through the JVM, or if you're using encryption, or it can go through zero copy streaming, which is not through the JVM, which is super fast and very, very efficient, like orders of magnitude more efficient than the old streaming path. But it can only do it if you send your entire SS tables all at once. Otherwise, you're going to be hitting the old slow path. You're going to get like 12 megs a second or 15 megs a second when you really should be getting like 100. So we're looking at literally an order of magnitude difference in performance. And by using UCS, more SS tables are going to be eligible for zero copy streaming, and as a result, you can run bigger nodes. So just this one thing can make your cluster significantly denser, which means less nodes, which means you spend less money. So imagine if you just upgrade and you can like decommission half your cluster, and you're like, cool. Like if the thing that stopped you before from running dense nodes was the ability to stream and bootstrap new nodes into the cluster and how long it takes, get to 5.0, that's completely fixed.
And John, I think you hit on
Okay.
something there too, that performance is money, right?
And that's, it's so funny because a lot of people will think about performance optimizations and they go, it's a 1%. It's like you're trying to just chase these tiny little numbers. And that is a massive misconception. Like that is so wrong. Most of the things that I've worked on have had like fundamental performance problems. Everything that almost everything I've ever worked on in my life, I'm not saying Cassandra specifically, just everything. There's always been some core issue, like just doing a database query in a loop synchronously. Like, I don't know if I'm sure you've seen this. A million people have done this. You test it out. It works great in dev because you test it on 100 rows. You put it in production against a billion rows. Guess what? It's going to take a long time. Just general inefficiencies like that, tiny little things that are adding up in production, and especially problems that are like ON problems. So if you've looking at it from an algorithmic complexity standpoint, ON problems are, you want to make sure you get those right. And that's actually a really good, like the patch that you and I have been working on. It takes an ON problem, which is how many chunks am I reading off disk? Let's read them one at a time. And it makes it a lot more efficient because now we do a big bulk read for a lot of data all at once. And then when we actually do that ON operation, we're not going through the page cache into disk. We're actually pulling it out of an in-memory buffer.
User memory, yeah.
Exactly. And it just makes it so much more efficient, like 10 times more efficient. So those are, originally we started talking about like, how do we get on Cassandra 5? Now we're talking about this. All this stuff ends up being related. It's like, it's really fascinating. And from the standpoint of, back to Cassandra 5 a minute, I have to talk about this because it's just so great. I'm actually working with a customer right now that's using Cassandra 5. We're rolling out incrementally all these features that have been added. Try mem tables. Great example of a huge win that I'm actually seeing between a 3 and 4x improvement in throughput at maintaining a constant latency. So we go from, let's say, 30,000 requests a second up to I think I was seeing at peak, it was like 150,000 requests a second. So there are monster gains to be made through the process of performance tuning, and personally, I'm trying to push Cassandra to get to where we have 20, 30 terabytes a node. And the cost just keeps going down over time. And you don't really see that a lot with projects like this, just huge gains over time. So my advice is get to Cassandra 5. It's awesome. There's been a ton of great work on it, and there's some amazing stuff in there.
A lot of exciting wins in Cassandra 5.
Yeah.
One other question here around cluster size. Any recommendations around cluster sizing in terms of node count? Our firm tried to suggest no bigger than 54 nodes for operational overhead and maintenance. Any war stories? So I'll start, and John and I have both run clusters over 1,000 nodes. I regularly have run clusters in the several hundreds of nodes. I don't want to come off as if that's entirely trivial. The database absolutely supports it. What tends to need more work is whatever control plane you're using, which is often custom or purpose-built for the company running it. So there are certain techniques like doing maintenance at the rack level. So like taking a subset of a rack down at once instead of like a single node at a time to make rolling restarts and upgrades faster, and a whole bunch of other techniques. But Cassandra itself certainly can handle hundreds or even low thousands, low 4 digits worth of nodes. Another caveat there is what your vnode setup is. Again, defaults. If you've taken the default 256 vnodes and you try to go to 1,000 nodes, your cluster will fall over. We are ON on the number of vnodes, and so as you add nodes with each, let's say 256 vnodes per node, you are increasing the size of that N. And so things like range queries happen ON on the number of vnodes, repair happens ON on the number of vnodes, and so that can lead to production issues at larger cluster sizes.
Yeah, 54 is should
Smaller.
be not a problem at all. Like I don't know where 54 came from in that, and whoever came up with that number, but we've worked on several clusters that have been in the thousands of nodes spanning multiple DCs, and the vnode thing is important, and that was changed in maybe 4.0. I think we went from the 256. historical information that was basically chosen because the V nodes were picked at random. Now there's an algorithm that picks them a little bit better, quite a bit better. Still not perfect, but there are my production advice is to use no more than 4. So if you want to write the tooling to manage the tokens yourself, like Netflix has, that's cool. That's fine. If you don't want to manage it yourself, 4 gives you the ability to incrementally expand by about 20%. So instead of having to like double the size of your cluster or move tokens around, you can add a handful of nodes and you'll actually, take the load away from the other nodes in the cluster, and it spreads it around a little bit better. But for production, no more than 4. That's like the absolute. I would never run more than 4 in production. And there's a really good paper by a guy named Joey Lynch, who did the math, and you can see how the more V nodes you have, the worse your availability is. And this is like mathematically proven. And my experience is also proven it as well. Like I've seen a 600 node cluster with 256 V nodes, and literally there were like, if you were to do node tool status, there'd be a different set of nodes down like every
time.
Like you would run it like 2 seconds apart, and it'd be like these 5 nodes are down. Well, actually it's these 4, and you're like, what is going on here? And it's just the worst. Like you shouldn't do that. Don't use that. And then there was a question I saw that someone asked, do V nodes or tokens?
I answered that. Yeah. So initial tokens is V nodes. Yes.
Yeah.
Or sorry, num tokens. Initial tokens is how you set specific tokens.
Yeah.
There was also a question looking forward about JDK 21 and ZGC. John, I know you've done some testing there. The question was in the context of Scylla. I think we'll leave that part separately. But there is some exciting GC improvements coming to the JDK that Cassandra is looking to take advantage of.
Yeah. So I'm actually in the middle of testing a Java 17 with Shenandoah setup. In fact, I'm going to be working on that later today. So I mentioned try mem tables. Like they're really nice because you can keep a lot of your data off heap. It works really well. And further reducing GC pause time is definitely possible. With Shenandoah, I've heard a lot of really good secondhand information on it, but I haven't verified it myself yet. So I'm trying to get this data taken care of. We should see pauses no longer than like 10 milliseconds. And that's kind of the same sort of promise that you get with ZGC. It's supposed to scale up to any size heap, so you can use larger heaps. So using huge heaps isn't really a big thing with Cassandra. It doesn't really buy you that much. So I don't care too much about big heaps. But I do care about the super low latency guarantees, and the numbers that we've seen people discussing on the Cassandra mailing list is like, you'll occasionally see a 3-second GC pause. Fine. Like I can handle that because right now a lot of the sorry, it's millisecond GC pause.
I hope you can't handle a 3-second GC pause. I'm going to bring one more question, and then I'm going to have to drop. I'll leave after dark here in the capable hands of Steve and John. There was a question about running single token versus vnodes at all, since that came up. So my short answer to that is if you're going to run single token, you better be prepared to hire the expertise required to do that. It is much more complicated, and many of the people who do it for legacy reasons. For example, they set up their clusters when the vnode algorithm was random only instead of deterministic, and that was suboptimal. When you choose single token, your operations get more complicated. You have to come up with an algorithm to generate the tokens. There are common ones out there, but there are some edge cases. For example, I've had our token generation algorithm accidentally generate the same token in 2 regions. You get data loss. And things like that. You need a lot of expertise to figure out how to not double the cluster. Shrinking the cluster also takes expertise. There's just a significant amount of Cassandra expertise required to run with single token. If it were me and I was a company not looking to bring in all of that expertise and I wanted to grow my expertise, I would start with a sane initial or num token setting. And like John said, that paper lays out what those sane settings are. For me, I largely believe that's 4 tokens. So with that, I will leave all of you. It was really awesome getting to share all this. Hopefully get to see some of you in our training and in the Cassandra community as well. Thank you all for all the questions. Part of the hands-on thing is that John and I love when the training and what we do is interactive. We don't like just talking at people. And so having all these questions was phenomenal for today. So thank you very much. And Steve
Jordan,
and
thanks.
thank you for hosting.
Thanks. Yeah, listen, thanks for coming on. Thanks for being our master today and joining the team. It's been brilliant. I'm sure we'll have you back again. Absolutely, you know,
Absolutely.
and bring the following with you as well. So have a great rest of the day, and thanks again for your time, Jordan. So, okay, well, we'll let Jordan go. John, we have still got a large following, my friend. We've got nearly 50 people. They're hanging on here. They're waiting for the latest and greatest of what you've got left, or if there's anything else that you've got for us. I was just wondering, actually, you mentioned about Cassandra 5 and some of the new features that are in there, and just calling 1 or 2 things out. Is there anything that particularly grabs you that you've had some particular experience on? You know, these are still quite new. People are perhaps still unwrapping them, perhaps in some instances. But is there anything that you can fast track us with on your experience with these?
Yeah, absolutely. I think for a little background information, Cassandra 5 was released in September, so we're only 4 months old. And generally speaking, the community is kind of slow to adopt new versions of databases. It's not really, people are typically not leaping forward very quickly, especially since some of the older versions of Cassandra, the release process wasn't as rigorous as it is today. The release process now is absolutely amazing. Like the tooling that's there for testing, the CI, the load testing, like everything that we're doing now, it's night and day. So to me, it's a lot safer to deploy new versions a lot earlier. So that said, like I already mentioned UCS, the Unified Compaction Strategy. I mentioned try-mem tables. Those 2 things alone can help you cut your cluster cost in half by just packing more data into each node, which is pretty amazing. Then there's also some storage engine level improvements. One of them is called BTI. There's a new taking the same concept of tries, which is a prefix tree. So we're basically utilizing prefixes in order to save space. It's a space saving technique, and it makes things a lot more efficient. So the new indexes that are the new primary index that we have is being written now using a new try index. It's a lot more efficient. We have Java 17 support, meaning that we can go ahead and start using Shenandoah is a lot more mature. You can technically put ZGC in, even though you have to enable it with a flag. I wouldn't quite recommend people just flip over to that yet, not without doing quite a bit of testing and understanding exactly what your workload looks like. And there's some, SAI. SAI is a huge one. So SAI is probably one of the coolest things that we've seen in a long time. So SAI has enabled both vector search and like a more classic secondary index type search. Now, I want to be really clear here. The ideal SAI use case is let's say I have a partition with 100,000 records in it. Let's say it's people by city, right? So you have all the people that are located, and your partition key is your city, or maybe it's a zip code, something like that. And then you say, well, I want to find everybody in that zip code that is 52 years old, let's say. Now, prior to 5.0 and SAI, your options were to either pull out the whole partition, so you pull out 100,000, or if you're in the middle of LA or New York, it's a lot of people, and then scan it, right? Incredibly inefficient. With SAI, you can put an index on arbitrary field, and if you pass the partition key, it will actually do a very, very optimized index search. And so it enables you to do less manual data modeling. You no longer have to have a users by zip and age table, right? Like, because that would have been how you would do it before. You don't need that anymore. Now you can just create the index on that field. And so one of the cool things about Cassandra is the size of the community and the number of people that depend on it for these, like, you know, massive applications, like all of Netflix. Like when you load up Netflix, like you're hitting Cassandra. It's a critical piece of infrastructure. So, you know, so we're seeing a lot of development on these features that are just like quality of life improvements. And the thing is that it's based on Lucene. Lucene has over 20 years of development. It's a great library. So we're taking advantage of that, and now we have really nice secondary index support in Cassandra. I don't recommend using it for full like cluster stuff. Like you don't want to say, give me everybody in the world that's 52. There, and I won't get into all the reasons why right now because it will take a while, but the architecture is very much optimized for searching within a partition, which is a big use case. There's a lot of people that are going to benefit from this. So, and then, you know, I mentioned vector search. It also powers vector search. So if you have a RAG application, so if you're like, you know, if you're going to work with an LLM and you have a bunch of, let's say, your data stored in Cassandra already, and you're like, well, you know, I have a product catalog in here, or I have a movie database, or whatever it is, and you want people to be able to ask questions to that LLM and be able to feed it the context of what's in your database, putting a vector index on your existing data and then being able to augment your LLM with contextual information so that it can give you like quality answers is pretty cool. So this is like, you know, this is stuff that everybody's excited about now. Like a lot of people are running this. And it's really great because the number of use cases for Cassandra just keeps growing. So it's like very rarely do you see something get better over time with more features and get faster. Like there's a it's just amazing at the rate that it is growing. Like every year we just see more and more cool stuff being added to Cassandra. We see, you know, I'm sitting here talking about getting cutting costs of running a cluster in half. Like, you know, if every year you keep cutting those costs in half, like that is absolutely amazing. So yeah, we're going to continue pushing node density. We're going to continue pushing cool new features. Cassandra 6 or whatever our next release is, you know, it's going to be, it's the same deal. We've got all this killer stuff coming up in it. So my personal take on it is look at what's coming up. If reducing your cost is important to you, that's a great reason to upgrade. If taking advantage of SAI so that you can have more efficient indexing, and by the way, this will also help you with cost savings, it's a great time to upgrade. I'm 100% behind the upgrade, and I've got some major like clusters running with 5.0 already. Teams where it's an app like critical piece of the infrastructure, and it works incredibly well.
That's great. Well, listen, John, we have got probably six minutes left, and then we're going to have a hard stop. So I want you to think of, if there was one thing that you could share with our audience before you go, what would that one thing be? So just have a little think about maybe what that is. But we do have another question coming in from John W. So John W says about speaking about Cassandra communities, where are people hanging out these days? Any popular chats? So I'm going to answer a bit of that first. We have quite a few, well, we have a Cassandra community definitely hanging out with us at AxonOps. So I would definitely recommend get on, register with us, make sure you get in our monthly newsletter, that you're coming onto these monthly masterclasses as well. It's a great opportunity, as we've seen today, to really put your questions out there and, you know, and push out some challenges that you might have, because we've got masters here that can do it. So we've got we're hosting a community. John, there may be some your side as well.
Yeah, we have. So there's the Cassandra Slack. That's the main one. So we have the ASF has a just general Slack for the entire Apache software foundation, and all the projects that are located under it. So we're in there. So if you go to the Cassandra channel, looking now, I see we have, let's see, how many people do we have? Just shy of 2,000. So if everybody that attends this were to join that Slack, if you weren't in there before, we'd make it to 10,000. I think that everybody would be pretty pumped to see that.
That sounds good.
Yeah,
John,
so I'm going to mark that as
Sebastian M, just a couple of questions. Sebastian M says, are SAIs also efficient for greater than or less than queries, or only for equality queries?
Yeah, you can do
Great question.
you can do inequality. So you
Okay.
can do that. Yep. That's
Great.
it's the same it's the same code path. So
Cool.
yeah, we're looking at
Keep-
it at a pretty efficient
Keep
tree
the questions
structure.
coming. We've got 3 minutes left, then we are gonna then stop. We've still got over 40 people with us. That is fantastic. Thanks for hanging in there, everybody. Paul C, good to have you on, Paul. So Paul's question is, speaking of Cassandra 5x, is the version constrained to the max number of tables per cluster? We typically run many 4x small clusters with up to 600 tables, and unable to expand horizontally due to this constraint.
Yeah,
Good question.
so yeah, the number of tables in a cluster is still going to be a limitation there. Generally speaking, if you have that many tables in a cluster, your performance is going to be significantly worse than if you have fewer. I've actually never in my life seen a use case where people had that many tables that couldn't be remodeled into a small number of tables. It's always 100% of the time of the cases that I've seen, it's always been wrong. So generally if you can solve the data modeling problem, then you can solve the other problem. So it's really important not to treat Cassandra like it's SQLite or Postgres or MySQL. Like some databases handle lots of tables really well. Right now, that's not Cassandra's sweet spot, although there are some folks that are working to improve that. But I would, with the current release, I would never put 600 tables into production in one cluster. I would
Okay.
never, ever do it. So I'm going to mark that as done.
Cool.
Yep,
All
we
right,
came from
listen,
Oracle. There it is.
we're up on our questions.
I
60
love it. Yeah.
seconds. John, I'm going to
Yep.
give you 60 seconds for final thoughts. Actually, we've just had one coming. Have we just had no, we haven't.
Yeah, I'm gonna go through these real quickly. The ones that I have time to answer. This question about backups, this is more complicated. Don't have time to answer that right now. I'm sorry. So let me just say, whoops. I'm gonna just clear that out of there. It's 5 minutes interpreting flame graphs. Jordan already did that. So Jordan said that the wider the thing in the flame graph, the more time it takes relatively. So you want to look for the thing that's really wide. I actually have a blog post about this. Go to rustyrazorblade.com. And there's a few blog posts on flame graphs. And I also have some on Bcc-Tools, which I mentioned already. It's really awesome.
I'm going to add one thing into that as well, John. So if you've got any questions, or if you want to explore those questions more, or maybe there's a question that you didn't think of that came up that actually you want to talk about that a bit more as well, go onto the AxonOps site, book an expert, get a meeting booked in. But we'll have someone on the other end. We'll get a master, one of these guys. It may not be John, it could be one of ours, our masters, but we'll make sure we can get that question answered for you as well. So we got a few seconds left, John.
Yeah,
and then I'm going to wrap. I'm going to make a wrap. We'll take a wrap, whatever.
Yeah.
We're going to wrap this.
So the last question I'll take is a bit, Abjeet says a bit off topic, but do you guys think having IO U-ring integration in Cassandra would improve the performance? I don't see why not. I don't have any hard numbers on this, but if I were to guess, maybe, but it would have to be coupled with some other architectural changes. There are quite a few architectural changes that are happening to Cassandra. As we take advantage of better hardware, bigger nodes, more CPUs, more cores, faster disks. We do find that some of the architectural decisions that were made in the past, they don't work as well going forward. For example, a really good, probably the perfect example, we talked about concurrent reads, right? Talked about concurrent reads and writes in that setting. It doesn't work so well if you're using a lot of lightweight transactions. The defaults don't. But if you're mixing different workloads, picking the right number there, not so great. So there's a lot of discussion right now happening in the how do we handle from an architectural level kind of rate limiting concurrency, and there's a lot of there's actually quite a few improvements that have gone in. We saw an improvement in 4.1 that's also in 5.0 that I worked on with Alex Petrov, and essentially just really trying to make sure that we handle load a lot better, and we shed load faster, and we recover faster. So I think by itself, if we were to just snap my fingers and say IOU ring, you're in, I don't think we're going to see any difference at all, because we need to make a whole bunch of fundamental changes along the way. So I think that will probably be one of the things that we need to do, but it will be coupled with a whole bunch of other things in order to make it actually effective. So a little bit of a complicated answer. Like with distributed databases, there's a ton of nuance, because this stuff isn't there's not like one thing going on, right? It's not like I'm running one type of query. It's like, now we're running SAI, we've got counters, we got lightweight transactions, we've got all this other stuff. Some things read before write, and how do we account for that in our concurrency controls? So as the database queries get more complicated, we need to be a little bit smarter about how we manage our resource allocation, and how we hand out, how we go to disk, how do we take advantage of the disk that we have, how do we make sure that we take advantage of all the CPU cores that we have? So there's a lot of improvements happening there. How are we just how are we better at running in the cloud? I think if you're interested, check out Cassandra 15.452. That's the patch that Jordan and I have been working on for a while now. It's like, how do we better take advantage of disaggregated storage? That means EBS, SANs, still popular, and there's nothing we can do about it. People want to run, people want durable disks. That's fine. You can do that. How can we best take advantage of that? How can we be nice and fast? It's all, there's unfortunately a million things that are directions that are being pulled in, and we're trying to accommodate everything. But that is my super long-winded answer to the IOU
that's
ring
great,
question.
John.
Yeah.
Listen, so much great stuff. Fantastic. We've still got 40 people with us hanging in there. They don't want to leave. But if you want to hear more from John, you know where to go. Get on into his training course and get to spend some real quality time with John and the team there. John, look, just want to thanks massively for being our master, or one of our two masters today on a masterclass. And we just want to thank you, audience, as well, for hanging in there with us for Masterclass After Dark. We really do appreciate all of your input and hanging out with us today. We're going to let you know who the winner is, by the way, who gets the free seat over this next week. So we'll let you know on that. Don't forget to come back and join us again on February the 26th. There's another masterclass waiting for you. So until then, take care, stay safe. And from all of us here at AxonOps, and from John and the team, and Jordan and everybody else, a huge thanks. It's a goodbye for me. And John, I'll let you say the final words.
Yes, final word, come to the training. There's only 12. So here's the thing. There's only going to be 12 spots open, and we're only doing it 2 or 3 times a year max. Like, this is something that I do because I love it. And I love sharing what I know. I've had people that have been Cassandra consultants take it. I've had people that have run Cassandra professionally for a long time. The feedback that we've gotten has been overwhelmingly positive. I really, really want to pass this information on to as many people as I can. I am limited by time. So like I said, 2 or 3 per year. So the next one's going to be in April. After that, it'll probably be July or August. Find out if you won the seat. If you didn't win the seat, come join. Like, you're going to love it. It's going to be the most fun. It's 6 weeks.
And we want you back here with us as well, John, for another session soon as well. So that would be really great.
Definitely.
Okay, well, thank you everybody again, and we'll see you soon. Come back and join us again on the 26th. Take care.
Thanks for having me. Later.